Hello and welcome to another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 6, Lesson 8 on percent review. Many of the exponential functions that we work with in the remainder of this unit are going to be based on percentages. All right? And so it's very important for you to feel comfortable with basic percent work, just basic percent work. So we're going to do a bunch of review on that in this lesson. So let's jump right into it. All right? Now, the fundamental concept of percent or percentages, there's a slight difference between those, but I don't care. All right, you extensively studied percentages back in 7th grade. That's the year that you kind of really dig into them, all right? The concept of a percent is one of the most used in everyday life, all right? A percent is simply a ratio out of 100 that compares two quantities in a proportional relationship, all right? So it's kind of like saying, like if I had like 20 kids in a class and 3 of them were left-handed, right? I could say the ratio of left-handed kids to all the kids was 3 to 20. But if I wanted it in terms of a percent, right, then I wouldn't want it as a ratio out of 20, I'd want it as a ratio out of 100. So maybe I'd multiply both numbers by 5, right, 20 times 5 is 100, and I'd say, well, 3 out of 20 is the same as 15 out of 100, so 15% of the kids are left-handed. All right, that's the kind of idea, right? A percentage is really just a fraction out of 100. 56% is 56 out of 100. 22% is 22 out of 100. 3% is 3 out of 100. It is so very important that you understand that idea. That being said, let's jump right into it in problem number 1. Jonathan is getting a raise from $12.50 per hour to $14.75 per hour. His supervisor, Michaela, got a raise from $22 per hour to $25.30 per hour. Letter A, how much in terms of dollars per hour is Jonathan's salary going up? All right. Well, you shouldn't need any help from me on that. By the way, make sure to have your calculators handy today. We are certainly going to be using them a lot to do some messy decimal division, and you may even want it on this problem to just do the subtraction. Pause the video now and figure out, just in terms of dollars, how much did Jonathan's salary go up? All right, well, it's simple, right? This is just subtraction, right? I can say, well, 1475 minus 1250 is going to give me $2.25 that Jonathan's salary went up. Now that doesn't seem like much of a raise, $2.25, right? But we want to compare that $2.25 to where he started in the next problem. Let's take a look at letter B. By what percent is Jonathan's salary increasing? All right, so again, this is really a ratio. I want to compare this to the original amount. Whenever we do a percent problem, we're always kind of comparing to the original amount. Now, the ratio of how much he got to what he originally started with is 225. This is kind of like my left-handers to everyone, compared to 1250, right? That's my actual ratio of how much the raise was compared to the total. But what is that in terms of a decimal? For this, I definitely need my calculator, and it's simple enough, right? I'm going to have 225 divided by 1250, simple enough, and that gives me 0.18, 0.18. All right? Now, keep in mind, 0.18 is the same as 18/100ths. And 18/100ths is by definition 18%. Right? So in other words, I'm just doing a ratio, but I need that ratio out of 100. And quite frankly, decimals are a great way to get there because 0.18 is out of 100. That's 18 out of 100. So Jonathan got an 18% raise. Let's take a look at letter C. Who received the larger increase in salary in terms of dollars per hour? So who got the larger salary increase, Jonathan or Michaela? Why don't you take a moment? You already know what Jonathan got in terms of a raise. Why don't you go ahead and figure out what Michaela got in terms of a raise? All right, well, we just got to figure out Michaela's raise. Michaela's raise was $25.30 minus $22. She got a raise of $3.30. So Michaela got the larger raise, right? I mean, Jonathan got $225, Michaela got $330, there's no question. Michaela got the larger raise. But let's take a look at letter D. Who received the larger percent increase in salary? So we know, right, we know at this point that Jonathan got an 18% raise, okay? What we don't know yet is what percent raise Michaela got. Why don't you figure that out and then tell me who got the larger percent raise? All right, well, we're going to do the same thing for Michaela that we did for Jonathan. We're going to take the raise that she got, which was $3.30. We're going to divide it by her original salary, which was $22. I'm going to figure out what that is in terms of a decimal. 330 divided by 22. That gives me 0.15, 0.15, which is the same as 15/100ths, which is the same as 15%. So even though Michaela got the overall larger raise, Jonathan got the larger raise in terms of percent. He got an 18% raise, Michaela got a 15%. So Jonathan got the larger percent raise. Now, you might say, well, you can't buy bread with a percent, and that's true, right? There's no question that Michaela's buying power went up more than Jonathan's buying power. But if they continued getting raises, Jonathan continued getting an 18% raise, Michaela continued to get a 15% raise, eventually Jonathan's salary would become higher than Michaela's salary simply because the percent raise he's getting is higher than Michaela's percent. All right, let's keep going. Ratios out of 100. Now you can almost always solve percent problems by setting up proportional equations that involve 100. We didn't really do that in the last problem, but we're going to take a look at that a little bit in exercise 2 and 3. Typically, you use cross multiplication to solve these types of proportions. So let's take a look at exercise number 2. Gabe is buying a pair of jeans at a local store that are priced at $45. He knows that the county he lives in has an 8% sales tax added onto the list price. If Gabe has a gift card for $50, will it cover the cost of the jeans and the tax? Show work to justify your answer. All right, so this is classic, right? One of the places that we see percent all the time in the real world is taxes. Money that the government charges you when you buy something. Okay, now what we have to do is we have to find out what 8% of 45 is, right? We need to find 8% of $45. And what that really means, right, is we want to say, well, look, X is to 45 as 8 is to 100. X is to 45 as 8 is to 100. Now, a lot of teachers will say, all right, do 45 times 8, do 100 times x, cross multiply, divide, and all that. No, not in this situation, right? I want to take you all the way back to the first day that we solved linear equations. What's happening to x? Well, we're dividing x by 45. How do I undo that and get x all by itself? Well, I am just going to multiply both sides by 45. Right? It would be actually just a little bit even silly to cross multiply, right? I just need to multiply both sides by 45 in order to undo the division by 45. Now, x, right, is going to be 8/100ths times 45. Definitely just want to bring that up. That's simple enough. Maybe whoop, that's not what I want. Come back to me. There it is. All right, I want 8/100ths times 45. What is that? That's 18/5. That doesn't help me. 3.6. All right, 3.6. Since we're talking about money, I'm going to say it's 3.60. Now, keep in mind, that is certainly not what Gabe is paying for these jeans. If it was, that'd be awesome, right? That's actually just the tax, right? This is just the tax. That's the 8% of our 45. So what I now need to do is take my $45, add to it my $3.60, get $48.60, and that is what Gabe is paying. And so the $50 gift card is enough, right? That was ultimately what we were trying to answer. Will he have enough to pay for both the jeans and the tax on the jeans, given that he has a $50 gift card? And yeah, it's enough because, well, you know, 50 is more than 48.6. Simple enough. All right, let's take another look at an tax problem, or not a tax problem, but a percent problem. Let's see number 3. The population of deer in a forest preserve is predicted to decline, right? That's another word for decrease, by 5% this year. If the current population is 560, what population is predicted for next year? What percent of the deer will remain? All right, well, given what we just did, I'd like you to play around with this problem. It's very similar to the last one, except at the end of the day, you know, after you find out what 5% of 560 is, you don't want to add that to the 560, right? You want to subtract it from the 560 because that's what's going on, right? It's declining. Pause the video now and see if you can do that. All right, so let's go through it. Now, the first thing that we need to do is we need to figure out what 5% of 560 is. Again, we can do that just like we did the last problem. I can say x divided by 560 is the same as 5 divided by 100. Now, you can cross multiply, that's fine, but again, I really advise you to just think about it in terms of solving those equations, right? I divide x by 560. To undo it, I multiply by 560. Again, I need to have my calculator out right now because I do not want to try to do that in my head. Okay, I've got 5/100ths times 560 gives me 28. Wonderful. 28. Now again, that's just how much the population has declined. So my new population is going to be 560 minus 28, which is equal to 532. Now, there is one other part of this problem, right? It asks, what percent of the deer will remain? Well, to do that, right, one way I can do it is I can do 532, those are the number of deer remaining, divided by 560, which is the number of deer I started with. So percent remaining will be 532 divided by 560. Now that's a ratio out of 560. If I want a ratio out of 100, what I'm going to do is I'm going to bring this up here. 532 divided by 560. That's 19 out of 20. Thank you so much, calculator. That's 0.95. which is 95/100ths, which is 95%. Now, to put it mildly, that answer shouldn't surprise us at all. If we've taken a population and we've decreased it by 5%, what remains is 95%, right? It should just make all the sense in the world. If I had actually decreased the population by let's say 20%, what would have remained would have been 80% of what we started with. So some of you probably could have answered that right away. Now, others of you, I hope right now are saying, man, I don't want to figure out what 5% of 560 is by setting up this equation and cross-multiplying or even doing this. I know a faster way of doing it. And that's what we want to review right now. Let's take a look. Although you can find a certain percentage of a whole by using ratios, which is what we've been doing, it's critically important that you don't, okay? In other words, it's critically important that you do it by just multiplying by a decimal. So let's review how that works. It's certainly something you've found before. Let's take a look at problem number 4. Consider the following problem. Let's say that I want to leave a 15% tip on a meal that costs $35. Letter A, Find the tip by setting up a ratio involving 100. Wonderful. Okay, so what I'd like you to do is work this problem out, letter A, just like what we were doing, right? X divided by 35 equals 15 divided by 100, etc., and figure out what tip we would leave on a $35 check if we were paying 15% in tip. Pause the video now. All right, well, again, it's simple enough. It's all right, I have X over 35 is equal to 15 over 100. I'm going to multiply both sides by 35. And by 35 over here, cancel, right? X is going to be 15 over 100 times 35. Bring me out my calculator. Let's see. So I've got 15 divided by 100 times 35. It's going to give me that nice fraction again. And that's going to give me a tip of $5.25. All right. Now again, that's not a bad way to do it. I'm not saying that. But we need to be able to do it faster than that. I need you to be able to say, if I say, figure out what 15% of 35 is, I need you to be able to do it in a single calculation right away. So let's take a look at letter B. Find the tip by multiplying $35 by a decimal less than 1. Why is this the same in A? Well, actually, let's use A to look at it right now, right? How did we actually calculate 15% of 35? Well, we did 15 divided by 100 times 35. Okay, and I really want you to understand this. This really goes to really a deep understanding about what a percent is. A percent is simply a fraction out of 100. So when I say that the tip is 15%, what I'm really saying is it is 15 100ths of the original, right? I am multiplying the original by 15 100ths. Now, what is 15 100ths as a decimal? Well, 15 100ths as a decimal is 0.15, right? So I can find out what 15%, that is literally 15%. 15% and 0.15 are the same thing, right? Because 15% is 15 100ths, and 15 100ths is the same as 0.15. And so I need you to be able to figure out what 15% of 35 is, not by doing that cross multiplying or anything else. I need you to just be multiplying 0.15 times 35. And there's that 525, right? That is how we are going to be finding percents each and every time from now on, all right? So let's summarize that right here, right? Finding percentages by multiplying. To find p% of a total of t, simply find the product of p divided by 100 times t, where often p divided by 100 is expressed as a decimal, right? I mean, you could write it as a fraction, it just gets bulky, right? And really remember that dividing by 100 is just going to take the decimal point in your percent and move it 2 spaces to the left. So let's get some work on this. This is just critical. Exercise number 5. Find each of the following. Write down the product you use to find your answers. All right, so look. If I want to find 20% of 85, what I'm really doing is I'm multiplying by 20 100ths, right? So just right away, I'm going to write this down just a couple times, right? But literally what I'm doing to find 20% of 85 is I'm multiplying 85 by 20 100ths. But 20 100ths is the same as 0.20, so I'm just doing that, and I want to be able to do that right away. Right, I just want to, all right, I've got, 0.20, which is the same as 0.2, times 85 gives me 17, right? 20% of 85 is 17. Simple enough, all right? Now, you should be able to do letter B pretty easily. Why don't you pause the video and go ahead and do that now. Okay, well, let me just view full screen. Move this over here. So I want 12% of 200. Now at this point I want to think about like, well, what is 12% or what is 12 divided by 100? Well, 12 divided by 100, I just move that decimal point 2 places to the left, and 12% of 200 will be 0.12 times 200. Without a calculator, I think I can do that. That's going to be 24. 12% of 200 is 24. Now, letter C, 6% of 550. That can throw people off because some people will say, well, that's 0.6 times 550. But keep in mind, right, that 6/100ths, which is what 6% is not 0.6, but it's 0.06, right? 6/100ths is 0.06. So 6% of 550 would be 0.06 times 550, and that one I don't think I so much want to do in my head. So let's bring it over here. Let me just clear this thing out real quick so we clear up the screen a little bit. 0.06 times 550 gives me 33. Okay, easy enough. What I'd like you to do is pause the video now and see if you can work through letter D, E, and F. I know letter D and letter F might look a little bit worse, but I bet you can still handle them. Pause the video now and see what you get. All right, 4.5% of 120. Now again, right, if I absolutely need to, I really want to think about 4.5 divided by 100. I move that decimal place two places to the left, and that's 0.045, right? So I want to multiply by 4.5 out of 100, or 0.045. So that's going to be 0.045 times 120. You don't want to multiply by 0.45. That would actually be 45%. But I can multiply by 0.045 times 120, and I'll get 5.4. Okay. 36% of 96. That's a little bit more straightforward of 1. 36/100ths is 0.36. So 0.36 times 96 it might not be the prettiest answer, but it certainly isn't a hard one to set up. 0.36 times 96 gives us 34.56. And finally, 2.25% of 350. All right. Now, very often, you will run into percents that also have fractions mixed into them. Oh, the tax rate is 8 1/8%. Oh, my mortgage is 4 3/4%, right? That's where you have to feel comfortable turning common fractions, okay, into decimals. In other words, you need to be comfortable with the idea that 2 1/4 is the same as 2.25. So if I then move that decimal place 2 units to the left, it'll be 0.0225 times 350. So 0.0225 times 350, and that's 7.875. Okay. So we have to be ready, especially at the high school level, for things like that, right? We have to feel comfortable at this point that when I see something like 2 1/4, that's the same as 2.25. I mean, if you saw 2 5/7, I wouldn't expect you to know what that is, but then again, percents typically don't come like that, right? You don't find a mortgage that has 2 5/7% interest rate on it. You know, it's quarters, eighths, halves, right? Tenths, things like that. All right. Just to make sure you understand this, take a look at number 6. Which of the following calculations would find 8.5% of 250? All right, take a look and tell me which one's correct. Well, again, 8.5%, right? 8.5%, 8.5 per 100. is going to be 0.085. And so we're going to multiply 250 by 0.085. It is really a percent, honest to goodness, is just a way of writing a fraction whose denominator is 100 without having to put the 100 there. That's all it is. In fact, that's why it's per cent, right? Cent means 100, right? That's what it means. A century has 100 years in it, right? Cent means 100. That's why there's 100 pennies, 100 cents in a dollar. So 8.5% means 8.5 per 100, which is the equivalent of 0.085. Believe it or not, there used to be something called a per meal, right? And that was a per 1,000, but it didn't like catch on the way a percent per 100 did, although it's still kind of used. If you look at batting averages in baseball, you know, when you see somebody that's hitting 350, that's actually a per meal. That is 350 per 1,000. Anyway, whatever. Don't want to confuse you more than I already have to. All right, exercise number 7. Let's take a look at one last one. The price of gasoline this week is $3.60 per gallon. It is projected to increase by 15% next week. Letter A, how much will it increase? And letter B, what will be its price next week? All right, we're going to work in the next lesson exclusively with things that are increasing by a certain percent or decreasing by a certain percent. I'd like you to try to work through this one. Well, the first thing I want to figure out is how much will it increase? They are literally telling me it's going to increase by 15% of this amount, right? So my increase itself will be equal to 0.15 times $3.60. All right, I don't know what that is, so let's bring it out. I've got 0.15 times 360. That's going to give me an increase of 0.54 or 54 cents. Right? But that's just the increase. Right? If I actually want to know what my price is next week, then I'm going to take my $3.60 per gallon and add 54 cents to it. That's easy enough. So it's going to be 360 plus 0.54, and I'm pretty sure that's going to be $4.14. All right, easy enough, right? If I'm told where I start and what percent that I either increase or decrease, it's easy enough to just figure out using that decimal multiplication and then add it to the original or subtract it from the original to get my final amount. All right, let's wrap this up. So today we did a lot of different review, right? Most importantly, just the idea of a percent being a ratio out of 100. But the real takeaway you want to come out of here today with is that when I'm finding a particular percent of a number, I want to do that by multiplying by the decimal version of that percent. So if I'm finding 25% of a number, I want to multiply by 0.25. If I'm finding 13% of a number, 0.13. 2% of a number, 0.02. Not 0.2, that would be 20% of a number. All right, so you do want to be careful, and you can always figure out what you're going to multiply by taking your percent and dividing it by 100 on your calculator. Of course, all that does is effectively move the decimal place 2 units to the left in your number, because that is the decimal equivalent of the percent. All right, we're going to get a ton of work with percents as we move on in this unit. For now, I just want to thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.